I'm going to start the stream. I'm going to go live. Okay, good evening, everybody, and welcome to another SDAA Virtual Astronomy Outreach event. My name is Gary Hawkins, and I am joined by my friend and colleague at the SDAA, Dave Decker. And we are going to do a talk tonight entitled After Messier Came Caldwell, a kind of tribute to Sir Patrick Caldwell-Moore. Dave is going to do most of the presenting tonight. Dave's a bit of a Patrick Moore buff, and so I am going to be a little bit more behind the scenes this evening, driving the equipment. And as usual, we're having our, the odd technical problem here, but it wouldn't be a live stream if we didn't have a technical problem. For some reason now I'm not managing to stack anything on my other screen. So anyway, we'll figure these problems out as we go along. I'm going to start with a little bit of a formal presentation, but before I do that, and one of the problems that we've been having this evening is our one of our webcams is not working. So I'm hoping well, actually, I'll just transition across to that. Dave, you're actually on the webcam there. Why don't you say a quick hi and then I'll go back to the introduction here.
Well, welcome to Oak Oasis. We are so very happy to be back here, and we give kudos to the County of San Diego for allowing us to come back, and also to Ranger Kyle, who is a prince of a guy who sets up for us and really jumps through the hoops to make things happen. So we're really, really happy about that. And we took a little hiatus here during the month of January to get away from things and do some other things, pursue some science aspects and do a little travel. So now we're back getting ready to take off again. So anyway, hopefully, could somebody in the chat room give us a little shout and say, yes, the audio sounds good? And since I don't monitor the audio, I'm hoping it's okay. And let's see. Oh, I see Mike Jerry is in, Kyle Ick, uh, Dennis Luttrell. Excellent.
Okay, great,
Welcome,
Dave.
everybody.
And as Dave said, we're at Oak Oasis Country Preserve in Lakeside, California. Oak Oasis is a fantastic little local park that we have here, offering about 400 acres to walk over and a 2.5 mile trail. In fact, it's one of the trails that we tend to come out to as a family on a fairly regular basis. There is group camping here, but it's not a regular campsite. But there's some great facilities here, toilets and so forth and so on. And if you do the loop trail, it takes you to a fantastic overlook of one of our local reservoirs. So that's well worth doing if you're in the area. And the link for Oak Oasis, which is a San Diego County Park, is on the slide being shown. Okay, and our location this evening is just a little bit east of where my home is, and probably a little bit north of where Dave comes from, and that moves us into slightly darker skies. We are in probably Bortle 5, Bortle 6 skies here, so conditions are a little better, and hopefully that will allow us to bring you some nice images this evening. And as Dave said, we're gonna, or as I said earlier in the introduction, we're going to be talking about Sir Patrick Moore. So I got a couple of slides here, Dave. So why don't you just do the introduction for Sir Patrick?
So Sir Patrick Caldwell-Moore, quite a character, a venerable amateur astronomer. He was a musician, made quite a bit of history, and had a TV show that lasted 50 some years. Just an incredible piece of work that he did. He was an amateur astronomer. We'll talk a little bit more about some of his stuff and his works a little bit later on. So tonight, as we've talked about already, we're at Oak Oasis. We will be talking a little bit about Sir Patrick Caldwell-Moore, and we will be talking about some of the events on the Caldwell list and why he named it Caldwell and so forth. So I think we already gave a shout out to Kyle, so thanks for that. So slide 5 there.
Oh yeah, there we go.
Um, so in December, Gary and I hosted a session, and it's actually from this very location, where we observed several of the Messier objects from the Messier Catalogue. And for those of you that need a refresher, Charles Macier was an 18th and 19th century French astronomer. He was a solar system observer and a comet hunter. Comet hunting was a very popular thing to do in the 1700s and 1800s. So while he was searching for comets and observing solar system objects, he would run across objects that were curious to him, and he would observe these and realize that they are not moving relative to the background stars, so they obviously were not comets. Well, he began to make a list of these objects and their locations so that he knew if he found something in that area of the sky again, he would recognize it as something he's already observed and documented. So this list became known as the Messier list, and it's basically a list of objects that are not comets that Charles Messier observed. And we went through some of those things in December when we were here before. Um, that list, of course, became known as the Messier Catalogue of 109 objects that are not comets. And they are a great list of bright, beautiful, and generally easy targets for modern astronomers, especially amateurs. And if you're in the northern hemisphere, there are a lot of great Messier objects to chase down. And it's wonderful to look at them, photograph them, and so forth. So they sort of become overutilized in the amateur market, especially when you're looking at outreach programming, where we tend to go show the things that we already know about, and we find that we go set up in a park or a school and we begin showing the Messier objects again, and they become very, very familiar to us amateur astronomers. And sometimes we forget that there are other things out there besides the Messier objects. So this was, I think, Patrick Moore's concern. As a TV and radio host, he explored the Messier objects a lot, and I think he realized that there were a lot of things out there that, um, other than the Messier list, that amateurs could take in, and that they're possibly missing those things.
And yeah, and so we ended up with the Caldwell list. And in addition to that, of course, Sir Patrick Moore, I grew up with as a kid. If you were interested in astronomy in that time, the Sky at Night was certainly one of the main shows that you used to watch. And so we got very used to seeing Patrick Moore on our TVs. And nice guy, although sometimes he does uh, come across a little bit on the gruff side. He's got kind of a little bit of a stare about him, as you saw from the first picture, which I will just bring up again. That Sir Patrick in its finest. But as a kid, we grew up with him, and it was tremendous to learn a little bit about astronomy. And I'm sure that's what inspired my dad to build our first pier in the garden more than 40 years ago. And anyway, so moving on, I'm going to be using my pretty standard setup this evening. It's a fairly old, 20-year-old C8 Smith Cassegrain. Actually, it's actually not quite configured as it shows in the picture this evening. I do have my tail rad there, In fact, I've got completely the wrong picture. I do have my tail rad there and the focal reducer. I am using my 533 MC 9 megapixel camera, but I must have clipped the wrong picture from my deck because my mount has changed now. I'm using an EQ6R, and also I have a guide scope, which is currently, is it running? Yes, I have a guide scope on here as well, which, funnily enough, is not playing ball this evening, which is kind of unusual. So we may have to go back and not use that. Anyway, it wouldn't be a virtual live stream without some technical problems. So anyway, based around my 8-inch Smith Cassegrain, we will be using SharpCat Pro. I'm using the beta version 3.3 this evening as our stacking program. The reason I'm using that is because this beta version of the software has a sequencer built into it, and I use the sequencer in order to control how I do my imaging. It makes my imaging extremely repeatable, going from um, image to image or target to target. Uh, I probably should say that the stars may appear just a little bloated this evening. I've been doing a lot of photometric measurements in the last couple of weeks, and so therefore I don't have a IR cut filter or a my usual CCD CLS filter in the optical chain. It's just straight through. So you may just see a little bit of extra bloat on the stars this evening. And I think the other thing you're going to see for some of the fainter objects, it's going to throw the color balance off a little bit on my images, but I'll try and deal with that as best I can. And a complete list of the hardware and software that I'm using. Um, I obviously grabbed the wrong couple of slides here because this one's not quite up to date as well, because this still shows the AVX mount. Basically a list of hardware and software is up here. I'm going to be running subs probably in the 30-second range if I can keep the guider working. If it leads to a little bit of elongation of the stars, I may drop that sub time down to about 15 seconds, which should probably deal with it, and we'll go into our first observing session. And we're going to start off in the western skies. We're going to be looking at targets that are kind of heading towards the horizon. And then at some point during the evening, we will move to the eastern skies where the targets are still rising. And my first target of the evening, Dave, is going to be NGC 147, which you're going to have to remind me of the Caldwell number
It's
of.
Caldwell's 17.
Caldwell 17. And Dave is going to talk to most of these targets this evening. I will say that I set the observing challenge in the Cloudy Nights February Observing Challenge, and most of the targets that you'll be seeing tonight were not featured in that observing challenge. So hopefully there'll be some new targets here for you guys. Of course, all of the Caldwell objects do have an NGC number as well. So you're going to hear me refer to them by the NGC number simply because as I use my Tor facility on my sky map here, cart to seal, it's giving me the NGC number, not the Caldwell number. So let me transition. That wasn't the transition I wanted. Let me try that again. And let me transition. So there we go. And by the magic of broadcasting software there, we have Dave next to the picture. And so Dave, you'll be able to you you'll be able to
They'll, they'll know who I am.
they will know who you are. You are right next to the picture this evening by the magic of OBS broadcasting software, which is what we're using this evening. So Dave, take it away on NGC 147.
So NGC 147 is also Caldwell 17. It is a dwarf galaxy. It's a satellite of M31, the Andromeda Galaxy. And so these two objects on the Caldwell catalog 17 and 18, are very close to each other. They're both dwarf galaxies and satellites of the Andromeda Galaxy. Um, I don't have a lot of notes about Caldwell 17. Um, it's about 10,000 light years across compared to our own galaxy, which is about 120,000 light years across. So you can see it's much smaller than Andromeda or the Milky Way. And uh, apparently there is not much star forming activity in 147 right now. Um, so it's an older population of stars, and so there's not a whole lot of information about it. But if you are a visual observer, you'll find it about halfway between M31 and the constellation of Cassiopeia. So it's in that region there. It's actually part of the Cassiopeia constellation, but it's a satellite of M31.
Yeah, and I think you guys can see that I am struggling a little bit with the color balance tonight. You can see towards the left-hand side of the picture that I have up on the screen, it kind of goes a bit reddish, greenish. And I think what's happening here is because I don't have my usual color CCD CLS filter in there, it is just affecting things a little bit. So hopefully we'll only see this effect on fainter targets. The brighter targets, I'm hoping we'll be able to get a nice dark background for you guys. But you can clearly see the elliptical or this spheroidal galaxy here, 147. It was discovered by John Herschel in 1829, so it's obviously part of the Herschel Catalogue. And its dimensions are about 15 arc minutes by 10 arc minutes with a visual magnitude of 9.5. And just to put that in context, my field of view, which you will now see fully on the screen, is about 27 arc minutes by 27 arc minutes. One of the things with the focal reducer is the apparent sort of magnification or field of view that you get. It kind of depends on how far back the camera is from the focal reducer. And again, due to the changes I've made in the optical chain recently, my field of view is slightly smaller than it normally is. It's normally around half a degree by half a degree. NGC 147 is about 2.5 million light years away, and as Dave said, about 10,500 light years across. So about a tenth of the size of the Milky Way. Right. So with that, we hopefully will find a slightly brighter target for the next one. I've just got to bring up my tour and move on to the next target, which I'm about to do. Yes, so we are moving now to NGC 185, Dave. So I'm going to slew the mount and I'm going to show you guys what I'm going to go through here. I'm actually going to before I do that, I am going to save. Well, actually, I'm not going to save the stack because it's not particularly good. But I am going to use my sequencer. So under my sequencer, I am now going to run my image DSO target. Have I saved the previous image? No. And now it's asking me to move the mount. So I am going to just, there we go. I'm going to,
So while you're moving,
sure.
Gary, I can answer a chat question.
Oh, right.
Question came up about how many objects are in the Caldwell Catalog, and there are 109 objects in the Caldwell Catalog. It is sort of the antithesis to the Messier Catalog of 109 objects. And I guess you could say it's sort of a tongue-in-cheek kind of a move that Patrick Moore made when he created this list. Um, and we can talk a little bit more about that later, about what came up and why he created the list. We have some great quotes from Patrick Moore himself. So stand by for those. But for now, there's 109 objects that are not Messier objects, and that's sort of the whole point of the list.
And if you're watching the sequencer, it's kind of doing its thing now. So basically, instructed me to go to carte de seal and move to my target, which I did. After that, it then waits for the mount to settle. It then brings up, it then invokes the plate solver to make sure that we go to the right place in the sky if we were off a little bit with our targeting. And now it's asking me to set the guiding going. So I am actually going to do that just to see if I can get the guiding going. And if I can't get the guiding going, then I will give up with guiding for the rest of the evening. And in fact, I can't even start the guiding at the moment. If I can do that, I'll get it going. If not, I'll just give up and go for slightly shorter exposures. So we are now moving to, or moved on to NGC 185. I'm going to start the live stack again. I'm going to put the name of our target up here. And let's clear, and we should start stacking now. So now that I've got control again, I am going to see if I can get my guider going. Not sure why the guider is playing up at the moment. Most people don't guide doing EAA, but since I've got a guider on the scope, if it wants to play, I will let it guide because it does improve image quality. Um, but if it causes me problems, then I'll just switch it off and do it the normal way, so to speak. So I've set my guider going. Oh, I've got Dave's face over the top. So there you go. I've set my guider going here. And you can see it trying to get the mount under control, which I can tell you just from looking at it, it's failing to do. So I'm going to stop it. I'm going to reselect. I'm going to try again. And we'll just see if this works. It's kind of funny. The guider works most of the time, but just occasionally, for whatever reason, it seems to get a little upset. And it looks like we may be having one of those evenings. So I'm going to switch the guider off now and leave that off now for the rest of the evening. And we're running 30-second subs, so I'm just seeing a little bit of elongation in the stars. I'm going to bring that sub time down to about 15 now. I'm going to bump my gain up a little bit to compensate. I'm going to clear my stack and we will try again. Okay, so Dave, NGC 185 is Caldwell.
NGC 185 is Caldwell 18. Um, so Caldwell 17 and Caldwell 18 are uh, both satellite galaxies of M31. They're also very close to each other in the sky, probably just about 1 degree apart in the sky. And so there is some comment in the Sky Safari notes that these two satellites are somewhat gravitationally bound to each other. So in addition to being possibly gravitationally bound to the Andromeda galaxy, they may be bound to each other as well. So it's an interesting pair. The difference with 185 or Caldwell 18 is that it appears to have some younger stars and younger star forming regions, whereas C17 uh, appeared to be very, very minimal star formation regions. So there's a little difference there. Uh, that's about what I have on these two galaxies. They're certainly a pair, C17, C18, and uh, they're in that local group and somewhat bound to M31.
Yeah, and this galaxy is, as you say, Just a tiny, yeah, a similar distance, and as you said, gravitationally bound, according to notes. Also discovered by Herschel, although surprisingly not in the same year as NGC 147, and considering that they are only about 59 arc minutes away from each other, I guess that's kind of a little surprising. Okay, we will now move on to our third target of the evening, and I think somebody commented there that we should use Sir Patrick, so we'll try and keep to the Sir part there, Philip. Nice to see you joining us this evening. I'm just looking down through the names as well. Jose, good to see you as well. And yes, Dennis is obviously doing well with the emojis there.
Yeah,
So jolly good, Dennis. Keep going with those emojis.
you,
Right, we're going to move on to our next target, and that is going to be, as I just wait for my tour software, this is going to be NGC 457. So I am going to again go into my sequencer. I'm not going to save that image because I've still got this color gradient. So let's just go back to my sequencer. And again, just one of the reasons I'm using this sequencer is just simply because it sets up exactly the same imaging parameters each time. And that way you kind of get consistent viewing, if you like, from image to image. The only downside is it does take just a few more moments to get things sorted out. So I am now slewing, as you probably. Oh, right. I am going to Dave. I've still got your face coming up all over my different things I'm putting up on the screen here. So I'm actually going to go to my. I'm going to transition to my ever working screen. There we
do you
go.
make me look good?
Yeah, well, I'll try and get you there when I've got the little gap for you to fit into, but
Uh,
I don't think you should have been in the middle of the sky map there. So I've slewed the telescope across to and
So while you're slewing,
yeah.
we do need to, and thank you, Dennis, for reminding us. We do need to put a shout out to NASA's great triumph today. The Perseverance team seemed quite happy. When I was watching the event, the landing, I did not see any of those "oh my God" moments that we've seen in the past. So I think it looks like they were pretty happy that things went as planned. And it was amazing. It sat down, and within minutes, they posted two pictures from the surface of Mars. Uh, just moments after after Perseverance sat down, and it was really a great moment. And so many years and so much work has gone into yet another rover for Mars. So a shout out to NASA and the Perseverance team for their accomplishments today.
Yep, and we are on target, Dave. I am
Hmm.
just I've got the target there. I'm just going to get the live stacking going once I add the target name. 457, and we have our first pictures coming up of the owl cluster. And although I seem to have lost my live stack window seems to have got disconnected from my the rest of my thing here. So if somebody can remind me, I know you SharpCap users out there, if somebody can remind me how I reconnect these windows, I would be appreciative. I can deal with it if nobody knows, but if you do know and can let me know, that would be great. And I can transition to bring our friendly guru here back onto the screen because now, Dave, you fit right back in the little slot that I had available to you. And this is a pretty a well-known cluster from the public outreach perspective. A lot of us use this particular cluster for outreach. Um, And I'm just gonna reduce my sub time a little because I can see that the stars are elongating. Um, okay, there we go. That's better. And this is a pretty little cluster that we often bring up at public outreach. So, Dave, why don't you?
It's amazing when you have the time to look at the sky and just think about things, you begin to see pictures. And over the years, over the centuries, uh, there have been records of people imagining pictures of things in the sky, and that's why the original constellations were given those fabulous artworks sort of thing that we now feel is sort of ridiculous. But at the point they were created, the stars and the formation of the stars cause someone to see those objects and to think about those things. So this particular object, Caldwell 13, NGC 457, is a favorite of those of us doing public outreach with kids because they really see this thing and have great imagination. It's called the owl cluster because originally someone thought it looked like an owl with two bright eyes and the wings spread out to the side. And that was one of the names that was given to the cluster early on. Uh, but I would ask the kids when we show them at schools, what do you see when you look at this cluster of stars? And they would tell us many, many things. One of my favorites is some about a third grade or fourth grade boy one night told me that it looked like the X-Wing Fighter from Star Wars. And it got me to thinking. It actually, to me, looks more like an F-18 jet going in the other direction. So we all have these crazy imaginations about what we see. But it is interesting because that imagination, those pictures we have in our mind help us to remember what we're looking at. And when we see it again and we know where it is, what direction it's going, it helps us to bring back that image of that whole formation of that part of the sky and what it meant to us. So that's pretty interesting. It's also been known as the ET cluster, which is interesting after the Spielberg film came out.
Yeah, I was just gonna say, Dave, that it's also known as the
Yeah.
ET cluster.
There- There's a little, some other science stuff. This is actually a cluster of stars. And the question has been, why are there two stars that are much brighter than the remainder of the cluster? And both in Robert Burnham's book and in Stephen James O'Mara's book discussing C13, they address this issue about whether or not these two stars might be closer to us than the remainder of the cluster. And they believe the cluster is now about 8,500 light years away. So, we're not sure um, exactly what it is. It changes with, every time someone measures it again. We know that the age of the cluster is about 20 million years, so it's a very young cluster, and the stars in general are fairly young. I think the question remains about whether or not the two bright stars are actually a member of the cluster. I see we have Phil Blanco in the audience here. He might chime in. He's might be a little bit more expertise in this particular area. But it's interesting to know that when we look at these clusters of stars, like the owl cluster or the ET cluster, we don't know from our perspective what the actual distance is from us to each of those stars. So it is quite possible that the brighter stars are actually closer to us and may not be part of the cluster. And it's a fairly common situation when we see an open cluster like this to determine what stars are part of the cluster and what stars are not. But anyway, the ET cluster, the OWL cluster, the X-Wing Fighter, certainly is a favorite of those of us that have done outreach with elementary school children.
And it's kind of funny, Dave. I don't think actually it shows perhaps quite as clearly when you're doing EAA as perhaps when you see it visually through a telescope, because with the EAA we're picking up so many more of the background stars that it kind of doesn't have quite that pop that perhaps it would do if you were looking at it visually. I mean, it's still very clear that you can see the shape here, but it really does pop, I think, when you look at it through visually, right?
I think it does,
Yeah.
and you're right. Through a visual telescope, the fainter stars in our image here are not nearly as obvious. So it makes the two bright stars that we call the eyes seem much brighter in comparison. So yeah, I think you're right.
All right. I am now going to transition to our next target, um, which is NGC 663. So I'm going to move, and I'm actually going to move away from my sequencer now. And the reason I'm going to do that is, as I said, it tries to ensure that I do exactly the same thing each time. So it's going to keep resetting my gain and exposure settings, which is going to be annoying. So I'm just going to go back to doing this manually now. So I've moved to NGC 663, which is
Uh, Caldwell 10.
Caldwell 10.
Yes.
Okay. All right, so we have moved there. I'm gonna do, I probably, can you tell me the target, Dave? Just, I'm just trying to work out wherever I need to plate solve.
The target.
Yeah.
Uh,
What is it? What am I, I'm looking, is it another open cluster?
yes, it's an open cluster.
Okay.
Um, I don't have its actual size here, but so Caldwell 10 or NGC 663 is another young open cluster, and the interesting thing about this open cluster is that it has a concentration of what we call BE stars. And again, Professor Blanco, I hope you don't chastise me for not knowing as much as I should about this, but the little bit of spectroscopy I've done, it states that the BE stars are unusual because they basically have hydrogen Balmer emission lines as opposed to absorption lines. And what that means is we're looking at these lines of particular kinds of frequencies of light that are in the BE stars are emitting peaks of light or intensity on those lines, whereas many of the standard type A stars or stars like our sun will have an absorption line because the outer layers of the sun absorb those frequencies instead of emitting them. So it's interesting that this particular young cluster of stars has a high concentration of BE stars, which are uh, show emission lines for hydrogen Balmer series. So it's a lot of science, but it is pretty interesting, and uh, it's kind of makes it kind of unique. So C10 or NGC 663 again was discovered by William Herschel in 1787, and the let's see what he says. I have some notes here. Um,
And this
hmm,
cluster is about 9 million years old.
yes, it's
So
fairly
it's a
short. Yeah.
relatively new cluster, and it's one of those clusters that's nice if you've got a relatively small scope and from your backyard. We do see some color variations in the stars, even on this particular plot. You can see these much hotter, sorry, much redder stars, which are much uh, effectively colder in temperature. The brighter the star, the whiter or the bluer the star, it typically is much hotter. But this is indeed a nice little cluster for the small backyard telescope.
So there's some other interesting things about this Caldwell 10 object. It's fairly close in the sky to the Messier object 103. And the interesting thing here from Sir Patrick Moore's perspective is that Caldwell 10 is much brighter than M103. And it's also about 1,000 light years closer than M103. And so it's amazing that Macier would list M103 in his list and not have seen this particular cluster that we now know as Caldwell 10. So it's this little tit for tat that we see when we compare the Caldwell list with the Macier list that makes the history of these lists interesting.
Okay, that looks fantastic. I think we will move on to our next target now, which is not too far away in the sky. And you'll actually, because of the way the observing list works within Carte de Seal, I actually order these targets going from west to east. So we kind of just are slowly working the telescope back across the sky. At some point, I am going to probably have to do a meridian flip here. But that's fine. It won't cause us any particular problems. So we are now going to move to NGC 891. And as we do, Dave will be doing the translation to the Caldwell Catalogue. Unfortunately, my observing list only gives me one of the two names that I have, and it's giving me the NGC number all the time. And this is a really nice target. So let's not describe it, Dave. I think until we get our first couple of images come up,
Okay,
okay? Because
sure,
it is a really pretty target, this
sure.
one. So I'm going to go back into I'm going to go back into Sharp Cap. I am going to do a plate solve to make sure that I am in the right place. And this target was actually in the February observing challenge on cloudy nights because it is just such a beautiful target, as you guys will see in a few moments. So having done the plate solved and having moved have it to correct very little error. I am now going to reset my stack and hopefully we will get to see our first image here in a few seconds. Oops, something went wrong there. Let me try that again. Did I not move? NGC. Oh, maybe. Oh, that's weird. Sorry, my scope didn't slew for some reason. I just clicked it and assumed it would slew. There it goes. Now I've slewed across to NGC 891. Okay, so let's try that again. Let's do a quick plate solve. I'll just let the mount settle a little bit. The EQ6R, it's a great mount. It's been a massive upgrade from the Celestron AVX. But the one thing with it is it just does take a little while to settle. Probably in the order of 15 to 20 seconds. I'm not too sure why it takes so long, but it does. So you have to allow for that when you are moving between images. Okay, so again, we're now in the right place, hopefully. I'm going to clear my stack and hopefully we will see our first image pop up in, I think I've got my sub length currently set for about 13.5 seconds. Okay, yes, fantastic. I'm going to clear the stack again because I can, as you can see, the mount hadn't quite settled. You could see the streaking on the stars there. So I am, but it's got it the second time, and this is a fabulous target. As you will see in a few moments, I will actually zoom in, and you can see this already beginning to form. So Dave, I think they know what we're looking at. So let's go with a little bit of the detail. This is Caldwell 23.
Caldwell 23. So it's up on the screen, right?
Yes.
Okay,
Yep.
so um, this is a fantastic edge-on galaxy, and it's uh, sort of northwest in Andromeda. It's very close to the star of Almach, which is a great double star target and popular in outreach programs. Um, so 23 it's an edge-on galaxy. It's about 13 minutes by 3 minutes in size. Does that sound about right, Gary?
13 minutes by 3 minutes.
Something like that,
Let me
yeah.
just zoom back out there
Okay.
quickly. Yeah, that would be about right.
So
Yeah.
the length of this galaxy is probably maybe almost half the size of the full moon across
Yes.
in
Hmm.
diameter, and so it's fairly large in the sky. Um, it has a nice history. There's lots of good stuff about this galaxy in Robert Burnham's books. Uh, we know that I think Robert Burnham actually referred to a sketch that was done by Lord Rosse, and that showed the dark lane across the center of the galaxy. And I am looking at, I'm a little bit behind Gary. I'm looking at the view, but it looks pretty darn good to me.
Yes, we got a really, and
Yes.
I've just zoomed back in again.
Yeah.
I zoomed back out when you'd asked me to check against the field of view, and you can really see the dark lane going through the center of the galaxy, and it actually, and you'll see it begin to form image-wise a little better with time here, but it extends from just past this star here all the way across to about here. So we're kind of this part out here is a little bit fuzzy. We can certainly see the core and the bump of the core and the very distinct dark lane going through the center of it.
So
Um,
this is another object that's fairly bright and fairly obvious that was missed by Messier on his list, and certainly included by Sir Patrick Moore on his. So
Yeah, and this galaxy is about 30 million light years away. It's one of a small group of galaxies, sometimes called the NGC 1023 group. And it basically contains NGCs 925, 949, 959, 1003, 1023, and 1058. So there's a few galaxies here, and in fact, we are going to be viewing a galaxy group, one of the later targets that we've got here. And this image in 1999 was actually imaged, this a galaxy in 1999 was actually imaged by the Hubble Space Telescope in infrared. And some of us are actually now trying infrared imaging. It's kind of interesting. You can either go from the high end of visual, if you like, I guess actually it's probably I describe that as the low end of visual. I got to think now. Yes, the low end of visual because the Armstrong unit's coming down, right, Dave?
I'm sorry.
I was just getting my, no, it's the high end of visual. So the wavelength is getting longer. Sorry. I was getting confused there. So you can either go from like red through to infrared, or you can just go straight into the infrared and see nothing in visual. And I do have a couple of filters that allow me to do that. Um, and it's kind of interesting the different view you get of some of these targets when you go into the near infrared. And the other thing that you pick up very well in the near infrared is carbon stars, which do not show particularly brightly when you're looking in the visual range. Um, okay. So, as you can see, this image is beginning to form reasonably well. I am kind of a little disappointed I forgot to put my filter in. I think we will be getting a slightly better image, but we are beginning to see the extension now of the galaxy going out almost to the end of where it actually, if you were to look at this, say in Sky Safari or on the internet or something, you'll see that this does extend a long way out. Um, and we've stacked about 23 images at the moment, so about 5 minutes of data, and it's a beautiful, beautiful image indeed. Okay, I think while that just forms for just a few more seconds, and I know Mike Jerry is on line. Mike is a great Galaxy great galaxy guy on EAA. He particularly likes doing galaxies, and he often shoots them in black and white with a black and white camera. And you do get a little bit more sensitivity with a black and white camera. So that's something as well that I might play with in the future. But for the time being, I'm just using the 533 color camera, which is a really good all-round general purpose imaging camera. But if you want to look at some galaxies and you're on YouTube, look up Mike Jerry's YouTube channel. And Mike, I'm not sure if you saw on Cloudy Nights today on the forum, there was an interesting response to a post I had made about near infrared imaging that led to a Japanese guy's website who images from Tokyo. Some absolutely tremendous galaxy images considering that he's imaging, under what are Bortle 9 skies, right? If you get the opportunity, it's probably worth taking a look at that website, and it's in the thread that I started around near IR imaging. Okay, so we are going to move on to the next target, which is going to be NGC 869, and this time I will actually watch my Sky Safari and make sure. Because actually, we can't really see the mount particularly well here. It's about 6 or 8 feet in front of us and kind of disappearing into the darkness. But we've just slewed across now to NGC 869. So I will go back into SharpCap. I will do a plate solve to make sure that we are centered on that target. Okay, we are indeed. And we will get, I'm going to reset my stack. And again, here you can see the classic example of how long it takes my EQ6R to stabilize. Here's my first image, and as you can see, even though I allowed probably 10 to 15 seconds between moving the mount and actually hitting the live stack button, I was blurred. So let's see, we'll start it again. Okay, that looks a little better. In fact, I might just clear it again and just let it go from there. Now this is going to image quite quickly because it is actually a double cluster. Although, unfortunately, because of the fairly limited field of view I have with this particular setup, I think we would really struggle to get both elements of the double cluster in. But what I can do, Dave, when we've talked about this, given a few of the technical details, is I can actually just manually move the mount across.
Oh, sure.
So we can move on to the other part of the double cluster as well. So NGC, this is NGC 869 and NGC 884. And the Caldwell number for this, Dave, is?
It is Caldwell 14,
Okay.
and I believe that Caldwell 14 encompasses both of the NGC numbers, so it encompasses the whole double cluster. Um, so the double cluster is spectroscopically, they're determined to be fairly young stars, but they've been and they're old enough that they've pretty much consumed most of the gas remaining in the cloud where they were formed. And actually, if you want to take a look at this, Robert Burnham has a lot of great notes about the double cluster in his discussion about things that he knew about prior to the publication of his book. So it's always good to see Robert Burnham's description of something from his perspective in the latter part of the 20th century compared to today when we have different kinds of science to determine the sizes and distances and ages of certain things. And but it's great to read that string of history, and Robert Burnham fills that slot. He does have a good discussion of the double cluster here. Um, we do know that the double cluster was known from antiquity. There's references to it from Hipparchus and Ptolemy. And we know it's the heart of the Perseid meteor shower, which is kind of an interesting kind of a thing. And yet Messier did not include it in his list, so Caldwell did. And so anyway, uh, many of us have seen a double cluster on many occasions, and it is another one of those favorites that we take a look at and in public star parties and so forth. Gary?
Yeah, and like Dave said, this cluster is, the first catalog occurred of this cluster back in 130 BC. So again, it's kind of surprising that Mazier did not get this in his Messier list because we are only looking at one of the two parts of the cluster. And I am looking at a picture of the complete double cluster here, trying to make sure that when I try and move on to the second part of the cluster here, I don't do the wrong thing and drive the mount in the wrong direction, which is highly likely because I'm actually struggling to work out which way I should go. So just bear with me here, okay? Because I'm going to try and find the other part of the double cluster. It's not very far away, so I am going to bring my exposure down. I'm going to see where that brings me in terms. Oh, I'm going to need to turn my life stack off. So let's do that. Okay, and I'm going to bring my gain up. So, okay, so now I'm actually viewing live frames. I'm not stacking. So now I'm going to move in one direction and see if I go in the right direction. So let's see what happens here. Okay, so we're moving, and yeah, I can probably change the rate a little bit over there. So I'm moving down. And I think I probably went in the wrong direction there. So let me go up again. Okay, and now I am going to move in the opposite direction. So, yeah, luck would have it here, Dave, that I've managed to go in three different directions so far, or two different directions, and go in completely the wrong direction both times. So I am going to come back the other way because it must be on the other side, surely.
You know, when we look at the double cluster in binoculars, direction is not too difficult. You just point the binoculars and there they are. It's just amazing.
Yeah, and it's very difficult for me because oh, okay. I'm going to do this. I'm going to cheat here. So actually, the alternative way of doing this is I just put in the appropriate NGC number into my. Okay, so okay, the NGC number here I need is for the other part of the cluster is NGC 884. So I'm going to select, yes, so I'm going to select that. Okay, the mount slewed, so I should be there now. Okay, so yeah. Okay, so this is the second part of the thing. So I'm gonna the cluster. So I'm gonna change my exposure back up to about 10 seconds here and bring my gain down. And let's see what happens. Oh, interesting. Haha. I just lost shark cap, Dave.
I don't like it when you say interesting, Gary.
No, no, that usually it usually indicates that something's gone wrong, and I got an exception error come up on SharpCap.
Yeah.
So
So for those out there that are watching our stream and are secretly sort of laughing about how things happen, we call this situation the whack-a-mole situation, where we sort of run across a problem and have to quickly make amends. So I mentioned one thing we were talking a minute ago about. We mentioned Ptolemy just briefly, and some of us here in the club, SDAA, have some good friends that live in Wales. And Teresa and Edward are wonderful people. She's a bona fide astronomer. She's a member of the Royal Astronomical Society. And she has some personal experiences with Sir Patrick Moore. We were hoping she might turn up tonight, but I had not seen her in the chat yet. She was on our program last night, and we had a good chance to talk a bit. But one of the things that she told me about Sir Patrick Moore is that he had a cat, and he named the cat Ptolemy, and that was apparently his favorite cat in the latter part of his life. So these little interesting pieces of humanity that we find about these people, we think of them as sort of gods that we can't reach out to, but in reality they are just regular people with normal struggles and normal pets and so forth. So that was just a little anecdote that I wanted to throw in there.
Yeah, I'm glad for the anecdote there, Dave, because it took me a little while to resurrect Sharpcap there. And that is, I guess, one of the problems of Sharpcap is an extremely stable tool, but I am using a beta version because of the sequencer, and so you can experience the odd problem here, and that clearly was a problem. But I think we are back, albeit that my color balance seems to have gone way off, but I'll get that corrected in a couple of seconds. So let me just do a few more tweaks here. Right, so I think we've got the set. Yes, we got the second part of the double cluster up now, Dave, which is NGC
884.
884. Thank you. Yeah, my right, there we go. So there we go. Okay, so yeah, there we go, Dave. You're back, and the second part of this cluster is looking really nice. And you can see a good selection of much cooler stars here. Three or four, in fact, there's five stars here. There's this one here, this one, and this one. There's another star in here as well, which are somewhat cooler, and they sit much lower down on the what we call the main sequence, which is there's a very interesting relationship between the temperature of a star and help me out here, Dave.
The temperature star and what were you saying?
It's the HR diagram,
Oh,
the main sequence.
yes. The brightness and the temperature.
Yeah.
So the brightness, of course, is the magnitude, and it's a vertical scale on the HR diagram, and the horizontal scale is the color temperature in variously in wavelengths or whatever.
I hope Pat wasn't on the thing there because
No, but we have Professor Phil Blanco
well, yeah, of
on
course,
this.
Phil's in my course, right?
Yes, and
So, yes, I guess I've been busted here, because both Phil and I have been doing I've Phil more from the perspective of actually seeing how the class would relate to his own classes that he teaches. Me more from the student perspective have been doing a course on photometry, and in particular the measurement of exoplanet transits, with Pat Boyce from the Boyce Foundation, which has been a fabulous course. Learned a lot, but apparently there forgot what the HR diagram was all about. So that was bad of me. Right. Okay, so I need to just try and recover a few things here because I things went slightly wrong there. Right, so we are having got I'm all over the place here now, Dave. There we go. Having got that image coming up nicely. Um, We that the particular cluster that we were looking at there was about 70,000 light years away, and we are now going to move on to NGC 1275. So let me do that. And my mount's slewing, as you can see on the screen. I'm now at the target, so I'm going to go into sharp cap. I'm just going to have to give that a little bit of time to settle because of the settling time on the mount before I hit the plate solve, just to make sure that we get the target in the center of the image. And this is one of my favorite, actually, it's one of my favorite images that I've shot this year. I'm not sure how many of these we're going to be able to pick out, but hopefully we can pick out a few. But this is a fabulous picture if we can get a good image of it. And it's a real shame that we don't have the guiding working because I would really like to do this with longer subs, but you know, we've got what we've got. So let's go from there. So we are settled. I am going to plate solve just to make sure that I'm exactly where I'm hoping to be. And you're still looking at the double cluster from our previous thing because I haven't reset the stack yet. So I've plate solved. My mount has just nudged itself a tiny bit, and I'm now going to reset the stack, and let's see what we get. And okay, I'm going to bring Dave across to there. Okay. All right, so we're getting our first frames coming through here, Dave. It's going to take a little while to pull the information out of these frames, but hopefully we will, in a few moments, see what is actually an incredible uh, cluster of galaxies called the Perseus cluster of galaxies. It's also in the area of the radio source Perseus A. Um, Another target that William Herschel is credited for discovering in 1786. And this was in the Cloudy Nights February challenge, because if we can collect enough photons here and we'll start to zoom in, you'll start to see why I think this is such a interesting picture of this part of the night sky. So this is Caldwell
Caldwell 24,
24.
and I have not researched this one specifically, so
Oh, okay.
I've got the Sky Safari notes, but
Okay. Well, Caldwell 24 is a massive galaxy cluster, as hopefully you'll see. The last time I actually imaged this, I was able to count 15 or 20 galaxies, but there are indeed many more. The galaxies are all rather small in size, often in the sort of 1 to 2 arc minute range. So they are kind of small galaxies. We're going to need to zoom in and take a look around. And the entire um, cluster of galaxies um, is 235 million light years away. And one of the things I always like to try and remind people when we say something like that is that you really are looking back into history here. The light that you're seeing hitting my telescope tonight is what left this group of galaxies 235 million years ago, since the speed of light. Light can only travel at the speed of light. It's a finite number. So these galaxies are an extremely long way away, but what you're actually seeing, and what always amazes me, is that you really are looking back into history when you do this. So if there was, for instance, a supernova in anywhere in that galaxy cluster today, it's going to be 235 million years before we will actually see it here on Earth. Right, I'm going to zoom into this image a little bit, Dave, if there are some other facts and figures that might be interesting.
I don't have a lot on the Perseus cluster. I believe that Perseus A is known as a strong X-ray emitter and probably the subject of radio astronomy. But I don't know any details about that. And you mentioned the cluster is about 235 million light years away. That's quite a ways. And
Right, so I'm just sort of zooming in a little bit here, and let's see if we can do a galaxy count. Um, and we are unfortunately not going to see as many galaxies as I would like to see this evening because um, we are we're imaging with shorter subs than I would like. But here we go. I think we can start to see. Let's have a look. If we follow my cursor down here, and I guess Dave's hiding a couple of the galaxies here, so I'm gonna move that. Here we go. One, two, three, four, probably five, six, seven, eight, nine, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. I'm guessing that's probably a galaxy there. 27. And I suspect that's probably a galaxy there. So I think what you're looking at here is about 30 galaxies in a less than half a degree by half a degree. So if you can imagine the moon and looking at the moon, the size of the moon, this is about the same size. And within that, instead of being the moon, we're looking at this whole group of galaxies about 235 million light years away, rather than the moon, which is about 1.3 light seconds.
yeah, something like
The
that.
moon is 1.3 light seconds. So the moon, the light that you see from the moon is 1.3 seconds old. The light that you're seeing today is way before the dinosaurs. Pretty darn cool, I think. So kind of I like this cluster. And again, my darks and flats, for those of you who are technical, will know that they kind of allow us to correct for some things are not working quite as well as I would like them to work tonight because this would normally be all black, this background, and you can see we are slightly brighter in the center than we are at the edges. But again, I kind of repurposed my equipment tonight from what I've been doing recently. So, but even so, this is a fabulous galaxy cluster and a pretty incredible image, really, when you kind of consider what we are looking at this evening. Um, okay. So I will now go into find my next target.
Gary is
Yeah.
wondering, should we jump into another
Oh, right,
couple
yeah.
of
Why don't we take
slides?
why don't, yeah, actually, brilliant idea. Why don't we do that? Why don't I go to the introduction slides and let's do a transition back to the slide deck. And yeah, um, Dave, you've put some information together for the folks on early star catalogs.
Yes. Is that slide up? I think
Yes.
yes.
Hmm.
Okay. Um, so this slide is a just a collage of a picture of some of the early star catalogs that we know about in history, and to me, the history of what we have done in the last couple thousand years in astronomy is just amazing. Before the telescope was invented, we had naked eyes, and we had no essentially no light pollution, and we had a lot of time to take a look at the sky at night because we had no TV. So um, we have some great catalogs, some great observers. They had a little bit weak on the science sometimes, but they were able to see things and record things. And obviously, many of those people, those astronomers, would write things down, make charts, and so forth. So early star catalogs is kind of interesting. The question came up in chat earlier. What is the Caldwell catalog and how many objects are in it? So um, it, the term catalog uh, can be used quite loosely just to mean anything. It could be a casual listing of something, or it could be an extremely rigorous listing of all the stars known in the heavens, like the current Gaia survey type catalogs. But I thought we'd talk a little bit about catalogs because when I was a beginning young amateur astronomer and I began looking at some of the data, I read about the catalogs. I was really confused. I thought that there should be a clear correlation of objects across catalogs, and all we had to do was find an object in one catalog and take a look at its correlation in the other catalog, and that all of the objects would be in all of the catalogs. And how naive I was. The catalogs are nothing like that. So I thought I'd mention that, especially for those of you that are not astronomers, that hear these terms and they wonder exactly what it is. So basically, astronomers through the years would observe the sky, and they would methodically observe it, and they would take notes, perhaps make sketches, and they would note the way the stars moved in the sky. They would figure out some way to show correlations between the different objects, and they would take all these notes and write them all down. So those catalogs, what they were actually looking at with their naked eye, for the most part, was stars. And so the catalogs are a tabulation or a catalog of the stars that they saw, how bright they were, maybe their colors, where they were in the sky, etc. So that's what the early catalogs were like. And we mentioned Ptolemy a little bit earlier. Ptolemy had a catalog called Almagest. It was, I think he created it somewhere around the 2nd century AD. And it was naked eye observations of stars. And as I recall, I think it's on the lower left side of this collage of on the star on the image there. And so it's more of a chart than we say an actual catalog. Then we have the rigorous work that was done by an astronomer in the 16th century by the name of Tycho Brahe. And his work was incredible. He found a way to measure the positions of objects in the sky much more carefully than just a plain naked eye. He did excellent work considering the technology in the 1500s. And he created a star catalog. And that star catalog is um, extremely important in history. So, and that is, we can see on the very far right of the collage, it says Tychonus Brahe, and that's the face, the cover on part of his catalog. His catalog is quite famous, so we don't want to go down that line too far. But anyway, he did create a catalog of stars, and it was one of the best ones for that era. Uh, then we have, shortly after Tycho Brahe, we have Bayer created, Johann Bayer created the uranometria, and it was based on Tycho's work. I think Bayer actually had that printed or whatever in about the early 17th century, 1603 or so. And he was using Greek letters for identification of a lot of the stars. And I believe, again, checking, I believe that's the catalog that's the face of it is shown in the center of that collage. The interesting thing here is he used Greek letters, and he broke down the sky into areas of the sky, constellations, and used Greek letters within those constellations to identify the stars. Later on, we have John Flamsteed. John Flamsteed created the Historia Coelestis, and his atlas of stars was published in about 1725. Now, this was after the development of the telescope, so he had telescopic capabilities as opposed to just naked eye. And he found a lot of stars, um, and he found basically that the Greek letters were insufficient to number the stars in a constellation. So he actually created a numerical system based on numbers to index the stars. And I think we have, I'm not sure if the lower right is part of one of his charts or not. It might be in that catalog. So except for Flamsteed, um, these catalogs were created before Galileo pointed the telescope at the sky, and they were all just straight naked eye visual attempts at listing the stars. But they were all serious attempts and historically important to us. Go ahead to slide 11,
Oh, yeah, sure.
could you?
You're there.
Okay. We're
Deep
a
Sky
little,
Object Catalogs?
yes.
Yeah.
So we're a little bit out of sync. He's at one computer, I'm on another, and there's about a 15-second delay before it goes to you folks. So I'm never sure exactly where we are. So following the catalog of stars, uh, let's see here. Let me get where I'm going to my notes, make sure I'm correct. So following the use of the telescope pointed at the sky, astronomers were seeing a lot more than stars. They were seeing other kinds of objects. They were finding galaxies, which they didn't know were galaxies, and nebulas of clouds of gas, um, globular clusters of stars. They're finding all kinds of things up there that were quite a bit different than just single stars. So the catalogs created after the telescope was applied to the sky usually include a lot of what we call deep sky objects today. And the deep sky objects are the things that are basically not just stars, but some other kind of a structure in the sky. So then we have the era, uh, certainly um, the most significant members of the time period of this catalog era were the Herschels, William Herschel and his sister Caroline, and then later on his son John Herschel. And the Herschels created um, an incredible catalog of, originally it was called the Catalog of Nebulas and Clusters of Stars. So the Catalog of Nebulas and Clusters of Stars was published in 1786 by the Herschels. And later on, John Herschel updated it, and republished the catalog. And he gave it the name the General Catalog of Nebulas and Clusters of Stars. That was published in 1864. And it included a lot more of the DSOs, uh, galaxies, nebulas, globular clusters, those kinds of things. So the next important thing about the DSO catalogs is that in 1888, at the request of the Royal Astronomical Society, of which Sir Patrick Moore was actually a fellow, um, uh, uh, the Royal Astronomical Society asked John Dreyer um, to publish a later version of the Herschel's works, and he published that and gave it the name, the New General Catalog, nicknamed the NGC. So as you know, Gary tonight has been using NGC numbers to actually navigate the sky, and that's pretty much the main catalog that astronomers, at least amateur astronomers, use today to navigate the skies looking for deep sky objects. So that's sort of a little history of um, the catalogs. Um,
Is there another slide, Dave, or are we?
no, I don't think
No, there isn't.
so. No, not yet.
And something else on catalogs.
Yes.
Recently, my interest has focused a little bit less from the observing of objects and more towards the measurement of individual stars. and doing photometry, which is the measurement of light coming off individual stars. And the reason that you do that is because you might kind of look up at the night sky and think that nothing's changing. Well, that isn't the case. There are stars up there that are changing in their brightness, um, some of them over a very short period of time, over over a much longer period of time, from days to years. And measuring those stars gives us a lot of information about what type of star we're looking at, and indeed whether it's a single star or a double star, such as an eclipsing binary. And so my attention in recent weeks has kind of been focused at that. And from a catalog perspective, we started out with the early star catalogs. If you go to Robert Burnham's book, for instance, most of the stars there are done with the Greek alphabet, and they're also done with numbers, um, 2, 3 digit numbers, and also double digit alphabetics. But that's not many stars. And then we ended up with the Tycho catalog, which is not a great, which is 100,000 stars or something. And but that isn't anything like the number of catalog stars that we've got out there now. And with Gaia, which is a space mission that has been out there cataloging stars, and they're now on data release 3. Um, we have databases that are millions of stars deep. And so you've got all of these different star catalogs. And then as you get into the individual breakdown of the types of stars, variable stars, etc., etc., we've gone from star catalogs that were developed 100 years ago for some of the brightest and easiest to observe variable stars to star catalogs now for variable stars, which again are in the hundreds of thousands. And just to give you an idea, we are already at something like 7,000 potential stars that have been catalogued with exoplanets. And that's planets that are known to be or at least looking at the light curve and the spectroscopy and other measurements, are inferred to be rotating around the star. And that's kind of one of the areas that I'm kind of getting into. And I am actually hoping in a future live stream to actually do a either a exoplanet transit or an eclipsing binary variable,
Yeah, that'd be great.
and actually do that so that you can actually see a target millions of light years away, and often very faint and way below what you can see visually. See the light curve change, and then we can discuss what that infers with respect to the star. Some really fascinating stuff. Um,
So I have one comment.
okay.
We use the term Hipparchus catalog and Tycho catalog and so forth. Uh, there is a tendency to name some of these modern automated catalog systems by older historical names. So don't get, um, the Hipparchus catalog. Doesn't mean that Hipparchus found all these things. It's just the name of the current modern catalog. So just make sure what kind of catalog you're looking at, how old it is, how it was done, and so forth. It's always good to know that. So tonight we're looking at the list of 109 things that Sir Patrick Moore uh, calls the Caldwell Catalogue. And uh, so we need to know that Sir Patrick Moore didn't discover these things, and he's not making a claim that it is a complete catalog of anything. He's not saying here's a complete catalog of this area of the sky or types of objects or whatever. It's not a thorough type of catalog. It's merely a list of interesting objects that he felt were not getting enough attention compared to the Messier list. So
And
when we
Dave,
use,
just quickly
yes,
interrupt you there. I've jumped forward a couple of slides just because one, it's got the picture of the Caldwell objects on, and it also references the sky and telescope thing. So
oh,
you might as well just mention that now before I go into observing session 2.
okay, sure. So we're talking about, are you talking about the publication slide?
Yes, the
Okay.
publication slides. Yeah.
So tonight and for this session, I always use Robert Burnham's notes. They're a little dated for modern stuff, but his content and his discussions and history is amazing. If you don't have Robert Burnham's collection of 3 books, uh, then it's something you should go look for. They're no longer in print, but they're available at fairly cheap prices at secondhand. Um, and for this session tonight, I used another one of my favorites. Stephen James O'Meara has a book out called The Caldwell Objects, and you see a picture of that cover of his book here. Um, the thing about O'Meara is he does go into history. He also goes into modern science concerning these objects, and he shows images and sketches, and so he gives you a great perspective. And in a minute, we'll talk a little bit about some of the things that he included in his book. There's also a book by Martin Mobley, who was, it's a much smaller book, but it's a great book. And the thing about this book here is that the author had a personal relationship with Sir Patrick Moore, so he had some good insight. And then, of course, this list, the Caldwell objects, um, became actually took on a life of its own after the list was created, and Sir Patrick Moore submitted the list to Sky and Telescope magazine, sort of on a whim. And Sky and Telescope picked up this list, and they thought it was great. And they wrote an entire article about this list of objects, and it took on a life of its own, and became known as, and actually was named by Sir Patrick Moore, the Caldwell list, which is the first part of his hyphenated legal name, Caldwell Moore. So that's how the list came to be. Uh, and I think in a little bit later, I'm going to discuss some of the history of what happened and how that how that list was made. But
Well, that
yeah.
that's pretty yeah, and this the Caldwell Objects book there is a great book, and that kind of leads us nicely into our next Caldwell object, which is Caldwell 31. And while Dave's been talking, I've actually been imaging that object, so I'm going to transition across to that view so that you can see it. We've already collected about 16 minutes of data here, and this is known as the Flaming Star Nebula.
Mhm.
Size-wise, the nebula is about well, it's certainly slightly bigger in one direction than my field of view and slightly smaller in the other direction. And it's an emission reflection nebula. The emission parts are mostly in the red. The reflection parts, and I'll actually be able to show you these a little bit more detail in a minute, are more the bluey, purpley colors that we see here. Um, and the Like I said, the nebula measures about 37 arc minutes across by 19 arc minutes and lies about 1500 light years away. So it's relatively close and is actually about 5 light years across. So it's a fairly large object. Now, you can see here, I'm going to bring up my histogram and huh, I'm going to bring up my histogram, and for some reason that didn't shrink the picture, which it should have done. Uh, Weird. All right, so now I'm going to just bring the red level down a little bit here, and by doing that, I'm bringing back this image. Here we go. You can now see some more detail associated, less with the emission side of this and more with the reflection side of this. And you can see these wonderful patterns here that we have of these areas of nebula that are being lit up by the bright stars in their close vicinity. And we've got some sort of weird ghostly shapes here. It's kind of cool. Um, it does look really quite ethereal. And over here, while we've toned down the red a little bit, you can see actually a very bright area of red emission, which is actual emission rather than reflection. So again, I go back to my color balance, and remember with all of this, the color balance that I can achieve through SharpCap, I can change that color balance. So, you know, um, what I'm trying to show you is as perhaps as close as you might actually visually. Well, actually, you wouldn't visually observe this from the Earth because the way your eyes react would show it more black and white. But trying to reflect more what it actually would really look like, if you like, in real life. But we can, with the histogramming functions over here, emphasize certain things. And again, now that I brought the red up just a few notches, you will see once again that we're emphasizing more the sort of nebulosity, the emission nebulosity as opposed to the reflection nebulosity. But it's a beautiful image. Let me just shrink this back down again so that you get that full image there on the screen. And this is Caldwell
This
31,
is
also
Caldwell
known.
31. Interesting aspect of the flaming star is that uh, the illumination of this nebula comes from a star which is named AE Auriga. And the notes from Burnham and from O'Meara indicate that AE Auriga was a star that had a close call interaction with another star in the Orion Nebula, and that really wasn't too long ago, about 2.5 million years ago, I think was the estimate, as I recall, and that AE Auriga was thrown out of the Orion Nebula and moving in the direction of what the flaming star is, and so AE Auriga is illuminating the flaming star uh, uh, nebula at this point. So that means it moved fairly quickly. 2.5 million years, it moved from Orion into Auriga, and apparently is still moving quickly and would probably leave the flaming star nebula area in probably around 20,000 years from now. So to think that a star that has moved from Orion all the way into Auriga through this nebula and will actually leave this nebula in the next 20,000 years tells you how dynamic and how quickly things can happen in universal time as opposed to human time.
Yeah, that's kind of interesting because again, going back to the just the variable star piece of it, people just don't realize how much things are changing out there, both in terms of the light coming from individual stars and their proper motion. And as Dave described there, some of these stars are actually moving around quite quickly, albeit compared to a human's life over quite a long period of time. But things are not static in the night sky. Things actually do change on a night by night basis. And in fact, I've been imaging an eclipsing binary recently. I'm doing quite a lot of imaging on that, and that's actually got a period of about 8 hours. So it goes through a full rotation of two stars around each other in a period of about 8 hours, which is incredible when you think about it. If you imagine
Hmm.
something like the sun and another star close by, and they're actually physically rotating around each other in 8 hours, that is must be pretty incredible if you were actually out in space somewhere close enough to see that happening. It must be a wonderful sight if you could. And in fact, to that point, I think this particular nebula that we're looking at here, Caldwell 31, is a really impressive nebula.
Nice
And of,
image, yeah.
of course, I have managed to not put a target name up there, but I am going to save this image because I think this is probably the first time I've seen this particular image. So I'm going to save that. I'm also going to do a slight color adjustment before I save it again so that I've got a couple of different views as to what's going on. Probably a little bit too much red, so I'll save that as well. I do like to keep a target database, a sort of record of all the targets I've looked at. So now we're going to go onto another nebula, which is actually significantly larger than the field of view for my camera. But what we're going to do is we're going to focus in on the center of the nebula. There's a nice cluster of
You may
stars.
have to do a flip.
The what, Dave?
You have to do a flip.
I'm not sure.
Be
Dave
close.
was asking if I needed to do a meridian flip, but we'll find out. So let me go into my sky map again.
Two, two, three, eight.
Did I pick the right one? Yes. Okay, so no, I don't think I do, Dave.
Okay,
But let's see. No, I'm still just. And
just
we're
close.
actually coming up to what's known as the meridian now. And the meridian is a point where the telescope will need to completely rotate about 180 degrees and to re-image on the other side of the meridian. So it does take a little bit of time, and it also ends up with the scope being significantly more off in terms of its tracking performance. But since we're running plate solving tonight, that's not going to be an issue. So I've moved my mount. I'm going to plate solve to make sure that my target is centered. We were about 0.08 degrees off there, which, in the scheme of things doesn't sound a lot, but because I've only got a half a degree field of view, that's about 20% off. So it's worth correcting for that. I am now I'm actually going to put a target name in here this time so that I can actually save an image with the target name. And this is NGC. Actually, I think because I'm on the cluster,
Two,
it's
two. You're on the cluster. It'd be
2244.
2244.
Yeah, okay. So I'm going to clear
That's
my.
C50.
Yeah. And what's the Caldwell number, Dave?
Caldwell 50.
Caldwell 50. Okay.
Caldwell 50 is the cluster, and Caldwell 49 is the nebula.
Okay. So we're seeing multiple targets here in the same field of view. The general when people image this, they generally refer it by the name of the nebula, which is the Rosetta Nebula, which is actually a large circular emission nebula. Um, but you'll see that my field of view is such that we only actually just get the center of the nebula, and actually the center of the nebula is somewhat dark, with the red of the emission nebula around it in looking very much like a rose, which is where it obviously got its name from. But we are going to be looking at the cluster of stars that sits in the center of the Rosetta Nebula, called NGC 2244, and the entire nebula falls under Caldwell 50. What was the number again?
The nebula
The Caldwell number.
is C49 and C50.
Oh, C49
Yeah.
and C50. Okay, so we're beginning to do our imaging run again. We're about 8 frames into this. I will do some adjustments on the histogram to try and get a slightly better picture. And so let me just do a color balance. Okay. Yes. Okay, so what we're seeing here is, I'm going to bring that red down a little bit. This area is actually, I'm going to just try and do some adjustments here, just to try and get this as good as I can get it, and then we'll let this image form slowly with a little bit of time. And I'm actually, one of the things you can do in SharpCap is you can, if you press the shift key while you're moving the mid-level and black level bars here, which I'm attempting to do, you actually get a much finer movement. So I'm actually using the shift key at the moment just to pull the black level across to the right, and then I'm going to pull the mid-level. There we kind of go. Yeah. Um, and the reason I'm doing that is because and it's again, I'm trying to illustrate that the fact that we have a relatively black area in here, and let me just make this a little bigger so that you can see it. A relatively black core to the center of the Rosetta Nebula, and the around that is the very first of many rings of nebulosity that form the rose itself. And in fact, this rose would extend probably, if you see where my cursor is now, if we could collect enough light, you'll probably see that the Rosetta Nebula would probably extend to about this distance in a very um, mostly in red, which is kind of where it gets its name from. And I can show you a little bit more of that red just by adjusting that histogram now. Okay. So I think we're beginning to collect a reasonably decent image, Dave. It's going to take probably a few more minutes maybe to get a little better. Um, but it's not the best target for this particular setup, but it is. We have got a very nice view of the central cluster there
Yeah.
of the Rosetta Nebula itself. And this, the cluster was actually discovered by John Flamsteed in 1690, and then later catalogued by Herschel. Um, there are various NGC numbers associated with the different component pieces of the Rosetta Nebula in general. And it's a very popular target at this time of year for the astrophotographers. If you go onto any of the Facebook pages or so that feature astrophotography, or if you're on the Cloudy Nights forum, this is a particularly popular target at this time of year. It's extremely high in the sky. My telescope is basically pointing almost vertically up. And so you are getting the least atmospheric distortion of the image that you can get, because you're obviously shooting directly up through the atmosphere as opposed to um, at a long angle across the atmosphere if you were, only at say 45 degrees elevation as opposed to 90. Um,
It's an interesting note about the discovery, which is allegedly assigned to Flamsteed. Apparently, Flamsteed's notes really documented only the one star 12 Monoceratus. And I think this came from both Burnham and O'Meara's books. Uh, so at this point, his work was like in the late 1600s,
yes,
1690.
1690, I
Yeah.
think.
So it's it's not known whether he was able to actually document other stars in that cluster as such. So there's some controversy about that, and both O'Meara and Burnham discuss that controversy about assigning discovery of the cluster to Flamsteed, because his notes don't really support that. So if that's not true, if he didn't actually discover it, I would say probably the Herschel's the one might be given
Yes,
credit
they were given credit.
for more documentation.
And it's interesting because in the time of the Herschels, they would not have been able to been able to see the nebula itself.
Correct.
They because they were doing visual observation, and because of the way your eye processes information, they would have just seen the cluster of stars, and they would have recorded that. They wouldn't have seen the red nebulosity. You can only really capture the red nebulosity if you're doing either what we're doing this evening, which is electronically assisted astronomy, or whether you're doing astrophotography, where the astrophotography guys will be taking subs, that's individual images that could be from, let's say, 30 seconds out to several minutes, and then stacking hours worth of data. The other thing with this particular target is that the emission that's coming from it is actually at a very specific frequency. And so they often use very narrow band filters to isolate that red color from the background noise. But it does require much longer imaging sessions because the Rosetta Nebula is primarily a H2 region. And it's at a distance of about 52,000 light years. And I'm not sure if you're picking up the rumbling that's going over our head at the moment, but it looks like we have possibly a police helicopter or something up above us, which is just going over
I
currently.
think they're after you, Gary.
Sorry, they could be.
Yeah.
My wife might be after me. Yeah.
No, Joy is after you.
And on that story, and since you mentioned my wife here, I must actually relay this story while we wait for this image to form. So the other evening, I am doing a photometric session out in the back garden with my telescope,
So you're going to
and
tell the story?
oh, I'm going to tell the story. I hope my wife is still listening or wherever she's on. But anyway, I'm out there, and the 2 or 3 hours goes past. I'm reading some stuff on the computer while the imaging is taking place. And I eventually decide to come in, knowing that my daughter and my wife have probably gone to bed because my daughter wished me good night about an hour earlier, and normally she likes to sleep with her mum. So I, came to the back door and went to open the sliding door, and lo and behold, it was locked, which was a bit of a disappointment because I didn't have any keys in my pocket. And now I'm wondering how I'm going to get into the house. So the first thing I do, of course, is I try and phone her phone, but that doesn't work because my wife sleeps with earplugs, and so she doesn't hear the phone ringing. And so I'm now thinking, what can I do? So I set the internal siren off in the house alarm system, making sure, of course, that I wasn't alerting the authorities at the same time. Well, this did the trick. About 2 minutes later, two very sleepy human beings came staggering down the stairs. And the surprising thing wasn't that; it was the fact that the first words that came out of my wife's mouth were, "Gary, why don't you have keys in your pocket?" Not, "I'm sorry for locking you out this evening," but it was quite an amusing evening. So they let me in, and they went back to bed again, and I continued imaging for about an hour longer. But it was quite funny. How I managed to get blamed for locking myself out of the house.
So Gary, do you have your keys in your pocket now?
I do. I've got my keys in my pocket, and
That's
I've
see,
been very careful to.
you learn.
I
You
do.
just like all of us,
Yeah,
we learn.
we do indeed. So that was quite a fun experience. So anyway, this image is a kind of probably as far as we're going to get it here. I'm going to take a couple of snapshots of the image. I'm going to bring up the red level as well, just so that we can see a little bit more of the nebulosity on the red side. Yeah, there we go. Just so I can get a couple of different images. Um, and the reason, like I said, the reason I do this, and just briefly, I'll kind of show you what I do here, is I have a target database, which I can bring up in, let's say, large scale icons. And so these are all the images, for instance, that I've collected of the various um, different targets that we've imaged over a number of EAA sessions. And we use these for presentations, obviously, and for showing. Sometimes we bring them up between different imaging sessions. Obviously, the FAA has released the flight path thing today because that's the second one that's gone over in a couple of
Apparently.
minutes. But I basically keep this large database of various images. Um, and this one, just I'll go off track just 1 second here. Actually, I probably can. I can bring it over here. in the sword of Orion, this is again a very popular target at this time of year. This is the Orion Nebula, which we I captured from the back garden just a couple of weeks ago, and a beautiful example of a nebula that we are able to see very well, both with EAA and astrophotography. Okay, so my next target, Dave, should be
Are you
some.
going to try Hubble's?
Yeah, I guess. I'm just seeing what my next target comes up as. NGC 2261.
Okay.
I'm gonna move my scope while you're gonna give us the Caldwell number.
Caldwell 46.
Caldwell 46. Okay, fantastic. So the scope's moved. And this, I'm not going to need to do a plate solve because I've literally only just moved a few degrees. Caldwell 46. Going to start my live stack. Thank you for the comments there, Robert. I'm glad you're enjoying the walk around the sky this evening, and we're obviously trying to. Oh yeah, that's the Hubble. We are obviously trying to bring you some of the fantastic Caldwell objects out in the night sky this evening. There are also many other fabulous objects. Of course, those in the Messier list, which are well documented and often viewed. And also there are many other fantastic images in the NGC catalog. So this Caldwell
Ooh.
object is actually named after Hubble. And I presume that's the astronomer Hubble as opposed to the Hubble telescope, right?
Yes. Let me go back to my desk.
Uh, yeah, Dave's
Where my
wandering
notes
around
is.
out here
I'm wandering.
this evening. I
I'm
was co-
wandering around out here to keep warm, Gary.
it,
This
it
temperature has dropped
It
suddenly.
is getting a little chilly, isn't it? Yeah, Dave's wandering around out here, and I was kind of like looking at him, thinking, how is his microphone still working? But it is, so that's good news. We are both using wired mics this evening. Um, Sometimes it's nice to have a wireless mic. So let's.
So I don't know who is credited with discovery, but I think what Hubble discovered was a variability,
Oh,
change in
right, okay.
magnitude, which is, this is more down your line of work, but actually they're talking about 2 orders of magnitude in a space of anywhere from months to years.
Oh, okay.
And so it's a very interesting, highly variable. It's not just a portion of a magnitude, but 2 orders of magnitude is a great change.
And just to put that in context, a order of magnitude is a change in light flux. Cheapers, that thing's low. Wow, we've got our third object plane going across, and that has got to be low. Do you
Yeah,
see the lights, Dave, behind you? Wow, that thing is low. It's not making much noise, but it's low.
yeah.
Anyway,
Huh.
an order of magnitude is 2.5 times change in light flux. So 2 orders of magnitude is obviously 2.5 squared, so about 5. So that's a fifth of 20% of the light. It would go from 100 to 20% over its variability period, which is, quite significant. So what we're looking at here is another, it's a peculiar emission and reflection nebula, the white areas being more of the reflection aspect of it. Again, credited to William Herschel, and first observed or at least catalogued in about 1783. Uh, Dave has mentioned the variability of the star that's associated with it, and it was Edwin Hubble in 1916 that did some of the first measurements using a 200-inch scope, not too far away from us in Mount Palomar. Um, so it was actually discovered. So I got to be a little careful here. It was discovered by Edwin Hubble in 1916, and the variability was first photographed by the Palomar scope in 1949. It's actually a fairly small target. We're looking at something about 2 arc minutes by 4 arc minutes, and its estimated distance is about 2,500 light years, and it's kind of a weird kind of shape there.
It's amazing that uh, because it looks like a comet, that this was not found by Messier. So that's just another comment of mine. One more interesting thing about this particular object, Caldwell 46, is that this was the very first object that was imaged by the Palomar telescope in 1949.
Oh, so that was the first time it was used for imaging.
Yes.
Oh, I didn't realize that.
Yeah. They, 1949, this is the first object that Palomar telescope imaged.
Oh, okay. I had in my notes that it was photographed in 1949, but I didn't realize it was the first object.
Yeah.
Oh, cool. And Mount Palomar is
They're
actually,
really after you, Gary.
yeah, I know. We are being buzzed now by all sorts of aircraft. I'm not
I'm not
sure
sure
what
what's
is
going on up
happening,
there.
but that is a helicopter, and it's pretty low. But yes, we've had four planes or helicopters or fly over us in the last couple of minutes. It's getting quite loud out here. I'm not sure what's going on. But anyway, let that pass a moment because I'm not sure if you can hear it in the microphone, but it's quite loud here. Okay. Yeah, it is a very interesting object, and actually, this is the first time I think I've viewed this object myself, Dave. So it's kind of cool. Always nice when you see a new target, and I'll definitely be saving an image of that in a couple of minutes. I'm not sure I see a lot of the emission part of what's going on here. I mean, the white areas, that has got to be the reflection nebula, right?
No,
I'm not sure I see so much on the emission side from this picture, Dave. Which actually, interestingly, because I have you side by side against the picture, I don't know if you've seen here, Dave.
yes.
I don't know if you've seen here, but I've got your picture next to the nebula. It looks like it's about to whack you in the ear. It looks like this
Yeah.
big flying dove
It's,
is coming in. It's
it's
going
like,
to give
oh
you
my
a
God, it's gonna get
ah.
me.
So
I don't know. I can't figure which side it is because things are turned around here.
yeah, right. Okay. Well,
I love it.
I am gonna save this image. That is another one for my target database. And we are going to, I know we've got a couple of other different things to look at.
Ah,
We're going to go to NGC uh, 2362, and we are going to meridian flip here now. So my telescope is going to, yeah, my telescope is going to completely, it's going to do a 180 around what's called the RA axis, which is the axis of the telescope that's pointing at the pole star. So it's going to take it a little while. And in fact, you can, if I zoom out here, uh,
cable's all clear.
I hope so. Yeah, that's one of the problems with a meridian flip is that the cables have got to move a long way, and there's always a chance that something will get snagged somewhere. And but I think we're doing okay. Yeah, I think we're good, Dave. No,
Yep,
yeah,
it's
we're
good.
good.
It's good.
Yeah. So my telescope has literally turned 180 degrees on its RA axis. Oh, wow, that is low to the ground. Okay, hold on. Okay. Right. So I need to and we are actually pretty low on the horizon now. We're probably at a 34 no, actually we're lower than that, right? We're 30 odd degrees down here or something. Anyway, right. Focus, Gary. Right. I'm going to definitely have to plate solve because there's a very good chance that we are not on the target. So let me do that. Yes, we're zero point 0.3 degrees off, so that's quite significant when you're only got a field of view of zero point 0.5 of a degree. So we are just nudging the scope. I am going to reset my stack. Okay, and as you can see, the scope's still settling, so I'm going to reset my stack again. And I'm going to do just give us 1 second. Okay, so it looks like we're going to find our target this time. And this we are now we've slewed into the constellation of Canis Major, and we are looking at a kind of interesting star cluster, which will hopefully begin to form a little bit. I can get my color balance right, balance my color, and let's see what we got here. Okay, Dave, so the image is beginning to form here, um, and I'll pass it back to you for a second.
So this is a very interesting object to take a look at. It's about 60 bright stars in sort of a box formation, and it's called a Tau Canis Majoris cluster. And Tau Canis Majoris is the main bright star in the center of it. So it looks sort of like a single jewel and sort of a box of stars around it. It's kind of the way that I've seen it. There's some controversy again about whether the brightest star is actually part of the member of the is actually part of the cluster itself, or whether it's something in front of the cluster. There's also some discussion about whether there's any nebulosity left in this cluster. So we talked about this earlier. Um, open star clusters are formed in a cloud of interstellar gas. And when those stars are formed, much of that cloud still remains. So, as in the Orion Nebula, like the picture that Gary showed a few minutes ago, we have lots of very young stars and protostars in the midst of a lot of gas. And eventually, as those stars mature, that gas will be consumed by those stars, and eventually what happens is the gas and the nebulosity disappears, is sort of consumed, and the stars interact with each other and begin to spread and so forth, and we have an open cluster with no nebulosity. So this one here, which is Caldwell 64, um, there's some question about whether there's any nebulosity left in this cluster, and there's also the question about the relationship between the bright star itself, Tau Canis Majoris, and the much dimmer cluster behind it. Lots of great discussion in Stephen O'Mara's book about this cluster, and he claims that, and he's quite an observer, he claims that the cluster appears fuzzy to him, but he thinks that maybe it looks fuzzy because our eyes cannot differentiate between a single bright star and the many small dimmer stars that appear to be in the background of it. So that's still kind of up in the air from an observational perspective. I don't know the science on this, but I do know that it's a absolutely beautiful thing to look at visually. A couple of weeks ago, I was down in Borrego um, at the Vallecillos stage campground, and had occasion to take a look at this cluster with my 10-inch Dob, and I was able to sketch it. And I think we can put that slide up here in a few minutes, show you some things. But anyway, it's a very beautiful cluster. It just sort of looks like that jewel is sitting on top of something like perhaps a fuzzy, um, you know, a blanket or something that makes it kind of stand out. But it is a beautiful thing. O'Mara calls it the Northern Jewel Box because it's sort of similar to the Jewel Box, which is another Caldwell object, Caldwell's 94. So one of the things you don't know yet about the Caldwell list is that uh, Caldwell, the Caldwell list was developed when uh, Moore was concerned about Macier's list not including southern objects. So Macier's list were all things that he observed from Paris. And Sir Patrick Moore says, well, we need to include many great objects that are, farther south. So Caldwell 94 is one of those more southern objects. When when Moore actually put the list together, he put it in a list which is in descending declination order. So he started at the north and worked towards the south. And so the low numbered items in the Caldwell list are very close to Polaris up in the north. And the larger numbered items are towards the southern horizon. So that's just kind of an interesting
Yeah, we got a
sideline there.
beautiful picture up on the screen of it, Dave.
Oh, I haven't even seen the picture yet.
Um,
Oh yeah,
just a really fabulous picture. Um,
and
uh,
you can see the difference between the one single star in the center, which is Tau Canis Majoris, and the other stars behind it that are significantly dimmer. And when you look at it visually, the difference is much more striking. And as you said earlier, Gary, photographically, we pick up the dimmer stars and are
yes,
enhanced.
yes, it's really interesting. And again, I've been playing around with um, looking at things a little differently in recent weeks with this photometry, and one of the things that just amazes me is that with this simple setup that I have here, which is basically a 8-inch scope, I've been actually imaging and able to pick up all the stars down to 18th magnitude in a given field of view, which is staggering because the visual seeing limit of this scope, Dave, is probably 12th magnitude or something.
If that, yeah,
Yeah, if that. And yet, when you start to introduce a highly sensitive camera, some sophisticated software, and stacking, you are able to bring so much more out in the night sky. But yeah, that this it's actually sometimes I always kind of think that clusters don't image quite so well in EAA, but this one actually is imaging really well today. Although I think it does probably show that my Smith Cassegrain collimation is out a little bit. If you look at the center star there, I think the circles that you can see around it, which are basically the light diffusing, are not quite central to the circular star. So I'm thinking I might have a little bit of collimation work to do
it's
here, Dave.
possible. Yeah,
But in general, it's that is a really pretty image that we're looking at.
I have one more comment
Yeah.
about this particular object. Many of you astronomers out there use an application called Sky Safari, and I use Sky Safari a lot. And Sky Safari includes photographs of many of these objects that we are looking at. And the photograph the Sky Safari includes of Tau Canis Majoris cluster was given credit to an imager by the name of Jim Tomes, who happens to be an SDAA member and a longtime imager. And so a shout out to Jim Tomes for his work. Many of his images are actually included in the Sky Safari application. So if you happen to see that name as you're browsing those images, just give him credit.
And Philip, who is obviously in the chat there, and I'm sure a number of you have actually seen it, but a fact that I didn't know, Sir Patrick Moore actually did 721 episodes of The Sky at Night. It's pretty incredible. Right, so now we're going to move on to our next target. It is getting pretty chilly out here tonight, and we've gone a
Yes,
few minutes already
and it's
past our.
also 12 minutes after 9.
It's also 12 minutes after 9, so we might make this our last target. It is certainly getting a bit cold, and for some reason, even though we did bring a couple of propane things, we didn't set them up, Dave, which was a
No,
bit of a
we haven't
mistake.
had time.
No, we didn't really have time, did we? So
What object are we looking at,
we
Gary?
are going to NGC 2392.
2392
I'm just
C39.
much higher in the sky.
Okay.
Basically, we're going straight up the meridian, as
Oh,
you can
planetary.
see.
Okay.
That's the great
Yeah.
grey line. Um, what one is this, Dave?
This is C39.
I
It's a
was.
planetary nebula.
Oh, okay, cool.
Yeah.
Great. Then let's
It's
finish
the
off on that.
Eskimo or clown face.
Okay, cool. Let's finish off on that then, because that's something different to just finish the stream
And then
off
we
on.
have a few slides, a couple slides we need to just comment on at the end.
Right. Okay. And while Dave's commenting on those slides, Gary will be jumping into his car and turning the heater on. Um,
As long as you have your keys.
oh yeah, as long as I got the keys, yeah. So I've plate solved and moved to my target. I am going to clear. What's the Caldwell number, Dave?
C39,
C39. Thanks. So
planetary nebula,
got it.
commonly known as the Eskimo or the clown face.
Okay.
It's about 4,200 light years away.
Okay. Oh,
And
got it.
let's see, zero point 0.8 by zero point 0.7 arc minutes. So it's pretty small, but it's very bright.
It's tiny and it's very bright. So
Yeah,
in fact, what we're
yeah.
going to do here is we're going to zoom in to start with, because it is actually a very small target. In fact, now that we see the target here, you can start to see the pixelation in the camera. So you can see how heavily we're zoomed in here. And I'm actually, because this is a relatively bright target, I'm going to bring my exposure time down. Probably going to have to reset my stack as I do that. And hopefully, yes, there we go. There we go. Let me just move that
Let's
over
see.
there.
Can you imagine that this was discovered by William Herschel yet again
This Herschel guy.
in 1787? Um, and he observed it from England. Oh, John Herschel observed it from England then in the 1820s. Um, interesting little things. So some anecdotal stuff about this great nebula, and I'm not sure if we have enough of it up to see detail yet. Oh, it's coming in, yeah.
We're getting it.
Um, so Robert Burnham says that this nebula looks exactly like its unforgettable features of the comedian W.C. Fields. so, so Robert Burnham saw W.C. Fields in this planetary nebula, and Stephen James O'Mara took a look at it, and he sees a cartoon lion with a large mane.
Really?
Yeah. So
I must be on
that's
the wrong planetary nebula, Dave.
no, I've actually looked at these, and I can see. I mean, I look at professional photos of this, and I think that's very possible. So the interesting thing is here, skilled observers of different skilled observers look at the sky and they imagine things differently, and as they do so, it helps them to remember what they saw and how it looked.
Well, I'm not sure that I see either a lion there or anything else. I see a number of circles, including the central star, which is why I brought the exposure down.
I
And just to give a little detail, and Dave, correct me when I go wrong again, and Phil, tell Pat that I'm probably going to make another mistake here. Um, the planetary nebula has nothing to do with a planet. It is actually a star that is in that's basically ejected, or a good deal of its surface layer, right, Dave? And
yes.
what we're looking at is more of the core of the star, and what you see is the expanding surface layer of the star that's been ejected from it as it goes towards end of life. Is that a fair
So
description?
what happens when a star is a fusion reactor of sorts, and mostly hydrogen, and the outer hydrogen layers are brought in, are sucked into the star by, gravitationally, and when they get to the core of the star, then the hydrogen is fused into helium, and that's the first layer of fusion for stars. Helium can then be fused into heavier elements and so forth in different layers. But what happens is eventually the hydrogen runs out and or slows down, and the fusion layers begin to slow down. So there's less of a outward pressure from the fusion. And when that happens, the core of the star collapses, uh, commonly into a white dwarf, and the outer layers of the star expand by thermodynamic expansion in the universe around it. So a classic planetary nebula um, will end up with a small white dwarf in the center, which is dense, but not dense enough to support fusion of heavy elements. And the remainder layers of the star expand into this large gaseous cloud, and um, it can be I guess it's an emission nebula. Actually reflects the nebula, the light from the
Yes.
center, but it may be both. But in what you usually see is a large cloud that has some interesting colors, shows very well with O3 filters, and you have a small white dwarf in the center. So your image here, Gary, if you look at the lower left side of the image, there's sort of a yellow band.
Yes.
If you rotate that up to the top,
Yes.
and so and it's like you're saying you're looking at it where that's the top of the image, then what you have is a good clear image will show a little bit of shape in the center, which
Yes.
looks sort of like a face.
Like a
And
toothpick.
yeah, and so
Well,
you can
not
see where
a
it can be
guitar
the
pick.
mane of a lion, or you know, a caricature of some, human face like W.C. Fields.
Yeah, I think I'm gonna have to get into a few drinks to see that one, Dave. I
Don't lay down on the table here too much, Gary, because you can just turn the computer.
Yeah, I guess I could, but it's much more fun just laying on the table. Yeah, okay. Well, I mean, again, it's kind of an interesting image, and it's a great way to finish this evening. You can see just how small we are in terms of how much we've zoomed in. I'm at 250% zoom here, so if I zoom back out, you can see now that our Eskimo Nebula is actually very small compared to our field of view. So with that, Dave, I'm just going to wander quickly across to the slide deck again, assuming I can get my mouse going in the right direction. And I'm going to transition to um, the slide. The first slide is a few more Caldwell objects, and then I think we've got just one or two more slides, and I think we're.
There, I have the one of the publications, and
Oh,
then
we've gone through that already.
I've
Yeah.
got a few Caldwell objects. So a few words. We talked a little bit, not too much yet, about the show that um, Sir Patrick Moore hosted for some 50 some years. And I think Professor Blanco gave us the dates in the chat. I have to go back and take
He
a look
did.
at it, but it's fairly
1957 to 2013.
13, yeah. And actually, I think he died like in December of 2012, and one or two more shows were hosted after that. I'm not sure if they were pre-recorded or if someone else did it, but
Well, I
anyway,
hope they were pre-recorded,
yeah.
Dave.
Well, if he hosted them, yes. The show did not last much longer after his death, but anyway, it's one of the. I'm not sure if it's the longest, but it's certainly one of the longest continuously running shows in history on TV, and it's to his credit that he had that dedication. So that show was called The Sky at Night, and many astronomers, going back into that time period, enjoyed seeing that show all those years. So that was wonderful.
And
Um, so this book that I mentioned earlier by Martin Moberly called the Caldwell objects. Uh, Martin Moberly was an associate, sort of associate or friend of Sir Patrick Moore, and I believe Moberly was another fellow of the British Astronomical Association, and he was a frequent observing companion of Sir Patrick Moore at Moore's home in Selsey in West Sussex. So he had a good chance to know him pretty well. And in Moberly's book, he explains that uh, Sir Patrick Moore had two nagging thoughts that he couldn't get out of his head. The first one was that there were objects such as a double cluster, which we looked at tonight, and and the Helix Nebula in Aquarius, which we have not looked at, but I'll show you a picture here in a minute, that were not included in the Messier list, but that were just as impressive, and that they seem to have been ignored by most casual observers. So, secondly, uh, Moberly writes in his book that Moore wanted to encourage astronomers to also look into objects farther south in the sky, because the Messier objects do not go very far south. And from Moore's perspective, there were great objects to look at in the south, such as the Helix Nebula. So, according to Moberly again, um, that was the motivation for Sir Patrick Moore to pen the list of 109 objects that were just as good as the objects on the Messier list and which had been somewhat ignored. And apparently, according to Moberly, he actually sat at his desk at his home in Selsey one morning and just wrote down these objects. Um, from his memory and from his notes and submitted it on sort of a whim to Sky and Telescope magazine. Well, Sky and Telescope Light magazine loved the idea. Of course, Sir Patrick Moore carries a lot of weight in this field right now at that time. So they published, actually, they had someone write an article and they published his list. And it became known as the Caldwell list when Sir Patrick Moore said I couldn't call it the M list because we already have an M list, Macier. So I will use my hyphenated name Caldwell and we'll call it the C list or the Caldwell list. So that's how the name came to be. So anyway, that's a pretty interesting thing. The list was first published in Sky and Telescope magazine in December of 1995. And I think a little while ago we showed the cover of that,
Yes, we did.
yeah, 1995. So anyway, that was pretty interesting. So now I think do we have the slide up,
We do.
Caldwell objects?
Oh no, we've gone past the Caldwell objects. We've
That's
got Sir
fine.
Patrick
That's
Moore
great.
and Brian May.
Oh, okay. So the Caldwell objects, that slide, is that the one we have up?
Yes. Uh,
Okay, I'm not on the live
Sorry,
feed.
we're on the Brian May picture.
Oh, okay. Well, the one that was up before it, there were images there. My sketch of Caldwell 13 on the left, which is the Owl Nebula, and then the Helix Nebula is down on the bottom, and
Yep, that's up
the
there now.
Tau Canis Major cluster is on the right. And so that's some of the stuff that I've captured lately.
Okay.
And another Caldwell object, which was not found by Macier, is the um, Sculptor Galaxy. And that's what's on the top of the Sculptor Galaxy,
Okay. Yep.
NGC 25. I can't remember the Caldwell number. So let's see, on to another little interesting thing here. Catching up on my notes real quick.
Yeah, and we've now got the Brian May
Yeah, and
picture.
so real quick, if you don't have the Stephen James O'Meara book on Caldwell, it's worth taking a look at the foreword. The foreword to that book was written by Sir Patrick Moore himself. And in that foreword, he explains his motivation and his process in developing the Caldwell Catalogue of 109 objects and his thoughts at the time that he submitted it to Sky and Telescope magazine. And his intentions are very clear. He wanted to encourage others to look at objects other than just the Macier list. And it's a wonderful short few words written by Moore himself that is worth reading. So let's see.
And just before we leave, Dave, while you were chatting there about those two slides, I did go and image one more Caldwell target,
Oh,
which we can just briefly bring up on the screen here.
sure.
So this is NGC 2403, which is a nice spiral galaxy. Let me just zoom out a little bit so that we can see it full frame so that you get an idea of its relative size to the moon. It's probably about a third of the
Oh,
size, quarter
C7.
to a third of the size.
Yeah.
And we'll zoom in a little bit to give you a better idea here. There we go. And we'll just reposition that so that it's nicely by the side of, there we go. And there, Dave. We've got NGC 2403 up on the screen at the moment.
NGC 2403 is
Yes,
Caldwell 7.
Cold War 7. Yes.
Yeah.
Mhm.
And it's significant for lots of reasons. It's a spiral galaxy, and um, apparently it's known for the number of Cepheid variables found in the galaxy. So there's a lot of science that can be done with when they find the Cepheid variables for measuring distance. There's a bunch of globular clusters, and they show some very significant hydrogen 2 regions, star formation, and so scientifically it has a lot of significance. And I haven't seen your image yet. Um,
Yeah, it's
oh, it's yeah,
we got a nice,
yeah, it's
relatively good
coming in
image of it
nicely.
at the moment.
So in the image, you can see those soft, fuzzy, not the start bright stars in front of it, but the soft, fuzzy areas are probably the, the star forming regions that are talking about. So that's a pretty interesting thing. Um, Lots of comments by both Burnham and
And you can see
O'Meara.
as time goes by here, the spirals are beginning to form now. Here's one of the
Hmm.
spirals here, another one of them here. And then if we had enough time, we would probably see some further spirals in this area as well. But a nice galaxy to finish the show off with, I think. Um, okay, and I think I will just transition now
Back to the slide
to,
deck to finish up, and
what was that, Dave?
back to the slide deck to finish up.
Yeah, I'm just going to go back to the slide deck to finish up. Yeah, great picture there of Brian May and
Yeah.
um, Sir Patrick Moore, who were good friends for a considerable period of time. I believe they knew each other for much of their adult life. And I believe there was an interesting thing at the end of that Brian May actually bought Sir Patrick Moore's
Yeah,
house.
I did not see Teresa Cooper on the chat tonight. She's the astronomer who lives in Wales and who actually traveled with Sir Patrick Moore in like 1974, I believe, um, and knew a lot about him. So she has told me a lot of things that she knew, and one of the things she mentioned was the relationship, the friendship that Sir Patrick Moore had with Brian May, who, of course, was a famous guitarist with the rock group called Queen. And Brian May also happens to have a PhD in astrophysics. So they had a lot of things to talk about. It's an unusual relationship, but apparently, as you can see this image, it's pretty clear that they did. And from a historical perspective, doing a little research, I found that um, at some point in time, Brian May purchased Sir Patrick Moore's home and rented it back to him. Uh, and so it put him in a good position financially. Um, Part of the problem was that Sir Patrick Moore would give away everything he had. He would love to donate to good causes to help students, and he had little concern for his own, um, his own possessions. So towards the end of his life, um, there was some concern about whether he'd be able to stay at the home. So Brian May, a good friend, says, I'll buy the home from you. The home by the name is, the name of the home is Farthings in Chelsea. That's what he called it. So Brian May purchased Farthings in Chelsea, and Sir Patrick Moore remained there until 2012 when he passed. So interesting relationships between all these people, and when we find out how real they are and their thoughts and what they did, it's very encouraging to me to just read that, hear all that interesting stuff. So that's what we have on the Caldwell Catalog of Objects. Um, Gary,
Fantastic, yeah. And I'll just finish off the stream by saying I hope everybody has had a fun evening and enjoyed things as much as we have, um, apart from getting a little cold now. We've had a great evening here. It's been an active chat discussion. We really appreciate everybody spending the time with us this evening and listen to us. Talk about Sir Patrick Caldwell-Moore and his famous catalogue. And I hope it encourages you to go out and look perhaps at a few more of his objects as opposed to the ones that we're often much more familiar with in, say, the Messier list. And I'll just say, please visit our website at sdaa.org. We have a new website up at the moment, which is kind of nice. It's a nice revamp. And you can also find us on YouTube, obviously. We have a YouTube channel and Facebook. And for those who are interested in some perhaps tutorials on either the open broadcast software or SharpCap, I have those on my own personal channel, my own personal YouTube channel, which is found simply under my name and just put EAA after it. But it's been a great evening. We've greatly enjoyed bringing this outreach event from the San Diego Astronomy Association, and we look forward to being able to bring you another event in the next month or so. So good evening, everybody, and thanks so much for joining
and
us
a real
tonight.
quick shout out to Astro Jenny and to Woody Schlamm. I see you in chat. Thanks for joining us.
Okay.
And thank you from the outreach perspective of the SDAA.
All right. Good night, everybody.
Good
Have
night.
a fun evening.